Researchers have tracked down that a thick layer of jewels might exist many miles underneath Mercury's surface. This revelation comes as we get ready to get our first close gander at Mercury through orbit. When we envision life on different planets, we should think about how the climate on those planets will impact what life may appear as. There are large privileged insights stowed away on Mercury. A little planet near the Sun, Mercury, which is small and blistering, has misled us for a long time. However, presently, robots in space are revealing unusual peculiarities. They have tracked down jewels on the most sweltering planet, and that is only the beginning. The interior of Mercury is unlike anything we anticipated, raising inquiries about how it contrasts with different planets. What else could Mercury be concealing? Stargazers and space lovers have long been enamored by Mercury, the littlest planet in our planetary group. Its baffling landscape remained concealed for hundreds of years, with its secrets just beginning to emerge after advancements in space research. In 1973, NASA's Mariner 10 mission began the search for answers about Mercury's surface. In 2004, the Messenger probe continued this search. Mariner 10 provided our first close look at Mercury, taking photos of its landscape, which was full of cavities and abnormal lines similar to the Moon's surface. This mission showed that Mercury's surface was rough and pitted with holes. However, it also uncovered a surprisingly strong magnetic field and a larger-than-expected core. These discoveries called into question past speculations about Mercury's composition. The Messenger mission, which stands for Mercury Surface, Space Environment, Geochemistry, and Ranging, began 31 years after Mariner 10. Unlike its predecessor, Messenger was designed to enter orbit around Mercury, allowing scientists to study the planet in more detail. The mission captured an astounding 200,000 images, revealing portions of Mercury that had never been seen before. One of the most fascinating revelations was that the darker side of Mercury contained surprisingly high levels of calcium and magnesium, sparking interest in the processes responsible for these elements. The mission also uncovered that Mercury's magnetic field was stronger than expected in the northern regions, which was an unexpected discovery compared to other planets. Mercury's structure and development process turned out to be much different from earlier assumptions. On Earth and most other planets, magnetic fields are generated by liquid iron moving in the core. However, Mercury's magnetic activity is driven by a unique core structure. Mercury's surface stands out not only because of its craters and lines, but also because of its extreme temperature fluctuations. During the day, temperatures can soar to 800 degrees Fahrenheit, 427 degrees Celsius, hot enough to melt lead, while at night, they can plunge to -330 degrees Fahrenheit, -201 degrees Celsius. These intense temperature shifts are caused by Mercury's thin atmosphere, which does little to regulate heat or maintain stable temperatures. Despite these harsh conditions, recent investigations have uncovered some astonishing features on Mercury's surface. In 2012, data from the Messenger mission provided evidence of volcanic activity, including pyroclastic deposits from explosive eruptions. This contradicted previous beliefs that Mercury was geologically dead. Even more astounding, in 2020, scientists announced the discovery of water ice in some of Mercury's polar craters. These areas remain in permanent shadow, staying cold enough to preserve water ice despite Mercury's proximity to the Sun. This revelation led to new hypotheses about whether Mercury could harbor extremophiles, organisms that thrive in extreme conditions, similar to those found in Earth's harshest environments. The latest mission to Mercury, named Bepi Colombo, was launched in 2018 by the European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA. It is scheduled to arrive in 2025. This mission will provide more detailed information about Mercury's surface, chemical composition, and geological history. From its unexpected magnetic field to the presence of water ice, Mercury continues to astound us. Ongoing research is uncovering even more unusual characteristics. Mercury's strange rotation and orbit. One of the most remarkable features of Mercury is the relationship between its day and year. Normally, we think of a planet's year as being longer than its day. However, Mercury is an exception. A year on Mercury lasts only 88 Earth days. A day on Mercury, one full rotation on its axis, lasts 176 Earth days. This means Mercury's year is half as long as its day. This strange timing creates fascinating effects. If you stood on Mercury's surface, you would see the sun rise, grow larger in the sky, pause, and then appear to move backward before continuing on its normal path. Mercury's rotation is too slow to keep up with its rapid orbit around the sun, causing this unusual phenomenon. Mercury's slow spin is believed to be due to a process called tidal locking, which affects a planet's rotation over billions of years. While the sun's gravity has gradually slowed Earth's rotation, Mercury is not fully tidally locked. Instead, it experiences a 3:2 spin-orbit resonance, meaning it rotates 3 times for every 2 orbits around the sun. These extreme temperature variations make it challenging for spacecraft to study Mercury. Probes must carefully navigate the planet's harsh day-night cycle and intense heat. Mercury's mysterious atmosphere and magnetic field. Mercury's exosphere, a very thin atmosphere, is another unique feature. This exosphere is constantly being replenished but also loses gas into space due to the solar wind, atomic decay, and micrometeorite impacts. Recent research has found that Mercury's exosphere contains surprising amounts of water vapor. This vapor is likely produced when hydrogen from the solar wind reacts with oxygen in surface rocks. In 2020, scientists were further surprised to find that Mercury's magnetic field is powered by a dynamic dynamo effect within its liquid metal core, rather than the traditional process seen on Earth. Despite its small size and slow rotation, Mercury's magnetic field plays a crucial role in protecting its surface from the sun's intense solar wind. Without this magnetic shield, Mercury's atmosphere would be stripped away, much like what happened to Mars. Mercury's hidden secrets. Mercury's hot poles, regions where the sun appears to pause overhead, add to the planet's mysterious nature. These areas are some of the hottest places on the planet, while regions near Mercury's poles remain in permanent darkness and are cold enough to preserve water ice. The ability of these shadowed craters to store ice in such a hot environment raises questions about the planet's potential to harbor life. Some scientists even speculate that these cold traps could contain other volatile substances, such as organic molecules preserved in the planet's coldest regions. The unusual day-night cycle and spin-orbit resonance create significant challenges for spacecraft. Bepi Colombo, for instance, had to perform multiple flybys of Venus and Mercury to slow down enough to enter orbit around Mercury. Once in orbit, the spacecraft will need to carefully manage its exposure to extreme heat during the day and conserve power during Mercury's long, cold nights. The future of Mercury exploration. New computer models suggest that Mercury may have once rotated much faster, but the sun's gravity. Mercury's enormous core. A mystery of cosmic proportions. One of the most intriguing aspects of Mercury is its unusually large core, which makes up about 85% of the planet's volume. This is significantly larger in proportion to the planet's overall size than Earth's core. Planetary scientist Dr. Nancy Chabot from Johns Hopkins University has led studies suggesting that this massive core may be the result of a major impact early in Mercury's history. The hit-and-run hypothesis. According to this theory, a large planetesimal may have collided with Mercury in the distant past. This colossal impact could have stripped away much of Mercury's outer layers, leaving behind the iron-rich core we see today. If true, this event would have played a crucial role in shaping Mercury's current form. Mercury's unexpected magnetic field. Another deep mystery of Mercury is its magnetic field. Despite being a small and slowly rotating planet, Mercury still possesses a global magnetic field, an unexpected discovery that challenged previous planetary models. Scientists initially did not expect Mercury to have a strong magnetic field at all. However, further studies revealed that Mercury's field originates from a thin layer of liquid metal surrounding its solid inner core. This discovery reshaped our understanding of planetary magnetism. Even more puzzling, Mercury's magnetic field is asymmetric. It is much stronger in the northern hemisphere than in the south. This unusual feature remains an active area of research. Volatile elements on Mercury's surface. In 2020, scientists discovered traces of sulfur, potassium, and sodium on Mercury's surface. These are volatile elements that typically evaporate at high temperatures, making their presence on a hot planet like Mercury surprising. One possible explanation is that these elements are remnants of past volcanic activity, locked into the surface before they could escape into space. This finding suggests that Mercury's geology is far more complex than previously thought. Could Mercury have hosted life? Mercury's harsh conditions make it an unlikely place for life as we know it. However, the discovery of water ice and the presence of volatile compounds raise new questions. Some researchers speculate that microbial life could have existed deep underground, where temperatures are more stable and water might persist in protected pockets. While no evidence of life has been found, the discovery of ice in permanently shadowed craters proves that Mercury still holds surprises. Future missions may uncover even more clues about its mysterious past. The future of Mercury exploration. With Bepi Colombo set to arrive at Mercury in 2025, scientists hope to gain even more detailed insights into the planet's surface composition, magnetic field behavior, geological history, volcanic activity, presence of water and volatile elements. Bepi Colombo's two orbiters, one from ESA and one from JAXA, will work together to map Mercury's entire surface, study its magnetic interactions, and search for more clues about its core. Conclusion: Mercury's enduring mysteries. Mercury may be the smallest planet in our solar system, but it remains one of the most fascinating. From its giant core and strange magnetic field to its extreme temperature shifts and hidden ice, Mercury defies expectations at every turn. As scientists continue to unravel its secrets, Mercury serves as a reminder of the many mysteries that remain in our own solar system. Each new mission brings us closer to understanding the origin and evolution of planets, and Mercury's story is far from over. Temperatures: these components might have been brought to the planet by comets or space rocks, possibly changing our comprehension of how Mercury's surface advanced. Maybe the most intriguing disclosure is the presence of water ice in forever shadowed pits close to Mercury's poles. In spite of being so close to the Sun, these regions stay cold enough to preserve ice. Besides, natural compounds have also been found in these districts, adding to the mystery of Mercury's climate. Mercury could hold hints to the origins of life in our solar system. These discoveries suggest that, despite its extreme conditions, Mercury could have the potential to harbor the building blocks of life. Mercury's role in the planetary system is becoming one of immense interest, with each new study adding a layer of complexity to our understanding of this enigmatic planet. One aspect of Mercury that has long bewildered researchers is its incredibly high surface temperatures during the daytime. While the planet itself is small and close to the Sun, the extreme heat it experiences isn't solely due to its proximity. The absence of a significant atmosphere to regulate temperature fluctuations is a major factor. As a result, temperatures soar to over 800 degrees Fahrenheit (427 degrees Celsius) on the sunlit side, yet fall to -330 degrees Fahrenheit (201 degrees Celsius) on the dark side. This dramatic contrast in temperatures creates an environment where survival, if possible, would be a testament to the resilience of any life forms, assuming they could endure such extraordinary conditions. In contrast to Mercury's extreme temperature swings, Venus, which lies just slightly farther from the Sun, experiences a runaway greenhouse effect that makes it even hotter than Mercury, with temperatures averaging around 900 degrees Fahrenheit (475 degrees Celsius). The extreme heat of both planets highlights the challenges astronomers face when trying to understand how solar proximity, atmospheric composition, and even rotational factors contribute to a planet's overall climate. In Mercury's case, its temperature extremes are likely a result of its slow rotation and the inability of its thin exosphere to retain heat during the planet's long nights. This exosphere, primarily composed of atoms such as oxygen, sodium, hydrogen, helium, and potassium, constantly dissipates into space due to the planet's lack of a true atmosphere. One of the most puzzling features of Mercury, as revealed by recent space missions, is the discovery of its hollow. These are mysterious, shallow depressions found mainly in the planet's northern regions. The hollows are believed to result from volatile substances beneath Mercury's surface reacting to heat and pressure, ultimately causing the surface to collapse. What makes this discovery so remarkable is that these hollows may be one of the last signs of geological activity on a planet generally considered to be geologically dead. This raises the question of whether Mercury still experiences some internal heat that could explain such unusual features. These revelations have led scientists to speculate that there may be more hidden within the planet's crust than previously imagined. The hollow formations were first documented by the Messenger probe, which mapped Mercury more thoroughly than any previous mission. This probe was able to photograph regions of the planet's surface that had never been seen before, particularly areas in permanent shadow. These areas, though shielded from the sun's intense heat, offer some of the best opportunities for scientists to study how different minerals and compounds react under extreme conditions. The hollow features themselves appear to be unique to Mercury, making them a crucial clue in understanding its geological history and the processes that may have shaped the planet's surface over billions of years. Mercury's history, in terms of its formation and how it became the planet we observe today, remains shrouded in mystery. One hypothesis that has gained traction over the years is the idea of planetary migration, the possibility that Mercury was once farther from the Sun in the early days of the solar system. Gravitational interactions with other planets, especially Venus, may have caused Mercury to spiral inward to its current position. This inward migration would have subjected the planet to intense gravitational forces, which could explain its dense core and turbulent history. However, this hypothesis remains speculative, and many questions persist about the exact processes that led to Mercury's present-day location in the solar system. Recent discoveries also suggest the presence of an unusual form of carbon, which may be linked to a diamond-like mineral. Scientists have recently theorized that these carbon compounds could exist in significant amounts within the planet's crust. This could indicate an unrecognized geological process occurring on Mercury, perhaps one in which the planet's unique chemical environment allows carbon to crystallize into diamond-like structures. Such a process would likely be impossible on Earth due to differing conditions. If these rare carbon structures are confirmed, they would add yet another layer of complexity to our understanding of Mercury's chemical makeup and geological history. Beyond the planet's surface, Mercury's environment plays a crucial role in shaping its potential for hosting life. Despite its harsh conditions, the discovery of water ice at its poles has sparked new discussions about the possibility of extremophiles, microorganisms capable of surviving in extreme environments, existing on Mercury. The presence of ice, which forms in permanently shadowed craters where sunlight never reaches, is significant. These ice deposits have been preserved for billions of years, offering scientists a unique opportunity to explore how water may have once influenced Mercury's geological processes. Although temperatures on Mercury are far too extreme to support life as we know it, the presence of water and organic compounds raises the possibility that microbial life could have, at some point, thrived in these ice-filled craters. A crucial factor in this potential habitability is the long-term preservation of organic molecules, which are considered essential to the emergence of life. These organic compounds, combined with water, create an intriguing opportunity for scientists to investigate whether the right conditions for life may have existed in the distant past on a planet generally thought to be inhospitable. It is these potential clues that make missions like Bepi Colombo so valuable, as they will allow scientists to conduct a deeper investigation into Mercury's chemical interactions, possibly uncovering more secrets regarding the existence of life. Understanding the origins of Mercury's magnetic field is also a key area of ongoing research. Unlike most planets, whose magnetic fields are generated by the movement of molten metals in their cores, Mercury's magnetic field results from a unique process. Scientists theorize that this dynamo effect is driven by a thin, partially liquid metal layer surrounding the planet's solid core, creating a magnetic field that extends far beyond the planet's surface. This magnetic field is crucial for protecting Mercury from the solar wind and maintaining its exosphere. It also provides insight into how planetary magnetic fields function differently across various worlds, such as Venus or Mars, where magnetic protection is either weak or absent altogether. The Bepi Colombo mission, which is expected to make significant contributions to our understanding of Mercury. It looks like you've provided a detailed and extensive passage on Mercury, covering its surface conditions, temperature extremes, geological mysteries, potential for water ice, magnetic field, and the role of the Bepi Colombo mission. If you'd like me to continue, could you clarify what aspect you want me to expand on? Would you like more details on Mercury's formation and migration theories? Further discussion on its geology and hollows? A deeper dive into Bepi Colombo's mission goals? A comparison of Mercury with other planets? Speculation on future missions and discoveries?